Hello, this is Neil Neslucin, Vice President of Marketing and Sales at Multify, and in today's webinar I'd like to speak about 100 gig Ethernet connections in next generation data center builds. We start off showing this quote from Charles Darwin, where he talks about the survivors being those that can adapt to change. This thought can be applied to the communications space in general, and specifically to the data center space and the components that fit into it. With the rise of cloud computing, CDN, and software as a service, there are new revenue streams for the data center operators to enjoy. And to do that correctly, they are looking at new data center architectures that need new and different components for the build. Today we'll talk about an important aspect of these new builds, the 100 gig Ethernet connection. On this page we see a basic representation of a data center network. Within the data center, at the switch level, there are many 500 meter, 2 kilometer, and even some 10 kilometer links for the largest data centers. And the interconnection links to the other data centers is also shown. These interconnection links realize the so-called mega data center, a collection of data centers around a metro region that operate as one logical data center. This new data center architecture requires flexible, high throughput, point-to-point connections where the capacity of the fiber is maximized. This leads to the lowest possible total cost of ownership and power. Additionally, the longer reach connections, traditionally served by expensive and power-hungry telecom equipment, need to be controlled and served by the Ethernet switch boxes. WDM technology can be used, but only at the component level, not at the platform level. This reduces cost and power consumption. The solution we're discussing today is a single wavelength solution, and you might ask why that matters. A single wavelength solution for 100 gig Ethernet results in the deployment of duplex single mode fiber, which is a great solution to future-proof the data center for eventual 400 gig deployments. It also makes the infrastructure build as cost-effective as possible, saving real estate and power, especially when deployed with QSFP modules. Finally, it allows for high-capacity connections between switches both inside the physical data center and between data center buildings, thus creating the mega data center. This can't be done with parallel fiber solutions. How do we achieve this single wavelength solution? Well, first let's talk about the natural evolution of optical transmission. It has always been to go to one wavelength for the signal to be transmitted. This is the lowest cost, lowest power, and most reliable method to transmit signals. It happened with 10 gig Ethernet, and with this technology will happen with 100 gig Ethernet. The first option to realize it is to use 100 gig optics. The problem here is they don't exist and won't exist inexpensively for many, many years to come. The next option is to use advanced modulation techniques, such as PAM4 modulation, with existing optics to achieve the 100 gig link. That's exactly what we've done. The enablers of this solution are DSP design techniques and CMOS silicon. Digital signal processing, commonly used in the wireless world, just consider your handset, and also used in the long-haul optical world, can be simply thought of as a technique to overcome the limitations associated with the traditional brute force method of optical communications that has been employed for many years in data centers. If it's good enough for the world's wireless networks, then why can't it be employed in data center communications? And CMOS is simply the most cost-effective way to bring this technology to market. Since cost is important in data centers, why wouldn't you depend on Moore's Law and massive CMOS manufacturing plants to bring down the cost of the advantage of utilizing the DSP? Now let's imagine the following. You're building your next-gen SaaS, CDN, cloud computing data center with the leaf spine architecture and many 100 gig ports in the switches. What if you could build that data center with duplex single mode fiber, setting yourself up for 400 gig? And what if that data center's 100 gig connections could be realized in only two different but very similar QSFP28 modules, handling all the important IEEE defined 100 gig connections of 500 meters, 2 kilometers, and 10 kilometers within the data center, and up to 80 kilometers from data center to data center, All this can be done with MultiPhy's FlexPhy technology. Finally, I'll leave you with this cartoon and suggest that indeed you sometimes have to think outside the box in order to achieve great things. I thank you for your time and invite you to contact us to discuss FlexPhy.